Good morning.
Hey, Mr. Levy. Let's see. Okay. Okay, it's 8 o'clock. All right, so this is our very last day to have class. Still have the final, of course. Um, I sent out to each of you your grades up until this point. So the only thing lacking at this point, and maybe you've already gotten it from Mr. Miller, your last homework grade. Okay, if you haven't already got it from Mr. Miller, you should shortly. But so what I sent out had the 9 homework grades prior to November 27th, and it had your 3 exam grades. Yeah, and you need to check those and make sure they're correct. And if they're not correct, well, questions about the homework grades should go to Mr. Miller. Question about the exam grades should go to me. Um, Yeah, and there's a record of all of this now. That's everything's been done electronically, so there are emails that have your homeworks and your exams in them, and it should be pretty easy to clear things up. Okay, so make sure you check that. Okay, let's see. Let me share my screen, and we'll talk about the final. Okay. All right, so my pencil here. Final is 8 to 10:30. Okay, Mr. Miller is here.
You told me I have to wake up tomorrow.
8 to 10:30 on Thursday. December 3rd. And remember, okay, I will post it. You can get started earlier than 8. I'll post it on Blackboard so that it will show up at about 7:30 a.m. And so that will give you some extra time if you feel like you need it. I must be able to see you on camera. Okay. That's an absolute requirement. If I can't, so okay, somebody has internet problems or whatever, backup times on campus. And actually, okay, we meet 5 days a week. So we are both a Tuesday, Thursday class and a Monday, Wednesday, Friday class. Same thing is true for my other class. So I'm going to list both of those times. So Monday, December 7th, 8 to 10. These are all 8 to 10:30. And yeah, that's officially our backup time, but also my other class's backup time. And there's always somebody that needs the backup, but it's only been one or two people every time. So yeah, you should automatically have this time period free. Okay. If I can't see you on camera, you're going to have to take the exam on campus either on Monday or Tuesday. You can use your notes on the final, just same rules as usual. Okay. Use your notes, use your book. You cannot use a calculator or use a computer to solve problems for you. That's not allowed. You must show me that you understand what you are doing. Absolutely must. And I will count off if I cannot see where your answers came from, maybe in the entire problem. But okay, any questions about the final? Are you all there?
Yes, ma'am.
Okay, good. Okay, good. Okay, so that's the deal on the final. And I'll probably post an announcement on Blackboard too, just to make sure this is clear. All right. Let's see. Okay, we were going through and working one problem off of each homework set. And I think we were up to Friday, October 22nd. Okay. The October 22nd homework and the October 15th homework both had, or was it October 16th? Whatever. Both had graphing problems on them. And you will have a graphing problem. But those are long for the most part, and I'm not going to work one. How about we had optimization problems on two different homeworks too. Let's do one of the optimization problems. Okay, I'm looking here. $300.5. Okay, how about number 7 from that homework? I think it probably should have been October 23rd. Whatever. Okay. A rectangular garden. Area 75 square feet is bounded on 3 sides by a wall costing $8 per foot. And on the 4th, by a fence costing $4 per foot. What are the most economical dimensions of the garden? Okay, so, well, the area, it's a rectangle. Okay, there's my garden. And let's call one side X and the other Y. And we know that the area is given. Okay, it's 75. And that's equal to X times Y. Yeah, you're told that the area is 75 square feet. So, well, that allows us to get rid of one variable. So Y is 75 over X. Mess that up. Also, and here, X has got to be greater than 0, and Y has got to be greater than 0 to make any sense. Okay, so what else? What do we want to do here? We want to say, well, to make the most economical dimensions, that means spend as little as possible on the wall and fencing. So let's see. This is Y, this is X. So on 3 sides, it's $8 per foot. And this one's 8. And then this one is $4. So I guess maybe the fencing faces the road or something, and the walls to keep stuff out. I don't know, whatever. That we don't need to know. But okay, so the cost of the fencing and wall, oops, we want to we want to minimize the cost of fencing and wall. Okay. And what is that cost? Well, the cost for a given X, well, let's just call it cost first. The cost would be equal to, okay, well, $8 for every foot for the wall here, $8 for every foot here, and $8 for every foot there. So that's, I don't need the dollar signs. I'll leave off the units for the moment. 8y plus 8x plus 8y. And then you have the fourth side, okay, that one with dimension x. And that only costs $4 per foot. So your total cost would be 8y plus 8x plus 8y plus 4x, which is 16y plus 12x. And then, well, your cost now is in terms of 2 variables, and that's not something we could handle. But that's where knowing that the area is 75 comes in handy, because that means that y is 75 over x. So now c is 75 over x plus 12x. So now I have a function of 1 variable. Okay. And actually, setting up your model correctly that's most of the work for these problems. Okay. But the rest is just a straightforward application of what we've learned about how you find maxima and minima. Okay. Which is what you do next. Well, if we want to actually minimize here. So we take the derivative. I could also write this as 16 times 75 times x to the minus 1. So that's going to be 16 times 75 times minus x to the minus 2 plus 12. And that's 16 times 75 over x squared. And there's a minus there, plus 12. Okay, well, x equal to 0. Well, x can't be 0, and that's not a critical number. Okay. Not only does that not make sense because your area would be 0 if you let x equal to 0. Right. Well, if x is 0, the area cannot be 75 square feet. So that's just x is not 0. So 0 is not a critical point, but can we set that equal to 0? C prime equal to 0 is equal to 12 minus 16 times 75 over x squared would say that 12x squared minus 16 times 75 over x squared is 0, which says that 12x squared, so the numerator has to be 0. And that says that x squared is equal to 16 times 75 over 12, which is, let's see, 4 over 3 times 75. 3 goes into 75 25 times. And that's 100. Okay. So that says that x should be, that's x squared, x be plus or minus 10, but minus 10 makes no sense here. Not for this problem. So throw that away. And then x is 10. And that's your only critical number for this problem. So, well, is it a minimum or not? X has to be greater than 0, remember. Let's check. And it all depends on what happens to the numerator there. So what happens there? If I put in x equal to 1, I would get a negative number. Function is decreasing. That's good. If I put in, okay, x equal to 100, I would get a positive number. So yeah, you get a minimum when x is equal to 10, which says that y is 75 over 10, which would be 7.5. Yeah. And let's see. The problem asks for what are the most economical dimensions of the garden? The most economical dimensions are 10 by 7.5. So x is 10 feet, y is 7.5 feet. Hey, any questions? Are you all still there?
Yes, ma'am.
Okay. 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 You can count on having it. Well, I don't know, maybe a related rates problem, maybe an optimization problem, maybe both. You'll have at least one of those two. Okay, what about that was exam 3. Okay. October 30th. Okay, October 30th had more optimization problems. And it also had the beginnings of the discussion on integration. So we were finding antiderivatives. Let's see. And we had some little initial value problems. I think I'll do one of those. How about part D of number 6? This is it's a what you call a boundary value problem. Instead of an initial value problem. Because, okay, you're given the second derivative. And you're told that the function itself at 0 has the value -1, and at pi over 2 has the value 0. Well, an initial value problem would give you the function value at 0 and then the derivative at 0. Or the function at pi over 2 and the derivative at pi over 2. This only gives you the function itself at 2 different numbers. And okay, these are not always guaranteed to have solutions, but hopefully I picked out one that did. Let's see. So we want to find f. Okay, well, taking the antiderivative of f double prime, that'd be f prime. The antiderivative of 2 is 2x. Antiderivative of cosine of x is sine of x. And you get that arbitrary constant. If you leave off this arbitrary constant in a problem like this, it's the kiss of death. Well, okay, you're assuming c is equal to 0, and it may not be. But okay, and we can't find c at this point because we're not given any information about f prime at a number. Okay, so let's go on to f. So that means taking the antiderivative again. Okay, antiderivative of 2x is x squared. Antiderivative of sine is minus the cosine. Antiderivative of c is cx. And then you get another arbitrary constant, d. And again, you don't want to leave it off in a problem like this because you're assuming that it's equal to 0. Okay, so we've got f of x determined to a certain extent. We still have these 2 constants that we need to determine, and that's where these conditions come in. We're given that f at 0 is -1, and putting that into my function, that's 1 minus, oh no, f at 0. X is 0. Not 1. To look at the right number. That's 0 squared minus the cosine of 0 plus c times 0 plus d, which is 0 minus 1. 0 times any number is 0. So this gives us minus 1 is equal to minus 1 plus d. And then that pretty much says d is 0. No, yeah. 0 is d. Okay. But so I still don't know what c is. But I know another thing about my function. I know that f at pi over 2 is 0. Okay, so that would be pi over 2 squared minus the cosine of pi over 2 plus c times pi over 2. We just found out that d was 0. Okay, and that says that 0 pi squared over 4. Cosine of pi over 2 is 0. Plus c times pi over 2. So minus pi squared over 4 is equal to c times pi over 2. So minus pi squared over 4 divided by pi over 2, I shouldn't have multiplied it out, is c is minus pi over 2. And, okay, so it did have a solution that says that f of x f of x is x squared minus cosine of x minus pi over 2 times x. And then I put the 0 on. You don't need to write the 0, actually. Any questions? Okay, let's see. Okay, so evaluating integrals. And actually, at this point, we are, I think, yeah, beyond the third exam. So November 13th. Yeah, the exam was November 6th. It's exam 3. Oh, let's see. I'm going to do one of those Riemann sums. And the formatting got messed up on that. So this is just hanging out there. Okay. A says estimate the integral from 1 to 3 of 1 over x dx using 4 approximating rectangles and the midpoints. And it says the midpoints, that means you want to take your sample points to be the midpoints. Okay. So this is asking for a Riemann sum. 3 curve looks like that. Okay, so interval is 1, 3. We're using 4 approximating rectangles. That means n is 4. So delta x would be b minus a over n is 3 minus 1 over 4 is 1/2. So my endpoints, 1 is x0, x1 would be 3/2, x2 would be 2, x3 would be 5/2, x3 would be 3. And we're using the midpoints for the sample points. So the midpoint between x0 and x1, let me do another color.
Wouldn't that last exit be x4?
Yeah. Okay. Thank you, Mr. Levy. Sorry. 2 x3s. Yes. Yes, indeed. Okay. So the midpoints between 1 and 1.5, it's 5/4. And then for x2, between 1.5 and 2 would be 7/4. And then x3 star between 2 and 5/2, that would be 9/4. So it's, yeah, going up 1/2 every time. And finally, x4 star would be 11/4. Okay. So the midpoints. Okay. So you're using the midpoints to get the heights of the rectangles. Okay. Okay. And that means that the Riemann sum would be, okay, be the sum as I goes from 1 to 4 of f of x by star delta x. Let's just write it out. So f of 5/4 times 1/2 plus f of 7/4 times 1/2 plus f of 9/4 times 1/2 plus f of 11/4 times 1/2. And I may as well factor that 1/2 out. F of 5/4. Okay. F of x is 1 over x. So that's just going to flip those fractions over. That's going to be 4/5 plus 4/7 plus 4/9 plus 4/11. Okay. And that's it. And if I ask you to do something like this, leave it like that. That's a number as far as I'm concerned. Okay. A perfectly well-defined specific number. I really don't want you to waste your time doing the arithmetic to get this into one fraction. But that is the answer. And that is the approximate area under the curve. It's not going to be a very good approximation because you only took 4 subintervals. Probably not too far off. Okay. Let's do. Okay, this is the material you're going to be tested on a little more in depth now because of the fact that you had not been tested on it before. So how am I doing here? Let's do an integral. Oh, maybe a definite integral. So this is number 3C. This is a definite integral. And remember, a definite integral is a number. An indefinite integral is a function or family of functions. Okay. Well, we have our one little technique. We also have properties of integrals and that we've learned about, but those aren't really techniques. Actually, U substitution won't help you here. But just expanding that 1 plus 2y squared will change it into the antiderivative of a polynomial, okay, which is easy. 1 plus 2y squared is 1 plus 4y plus 4y squared. And that's equal to, y plus 4y squared over 2 plus 4y cubed over 3. Yeah, I'm breaking it up into 3. You can do it all as one if you want. Y. Okay, just checking there. So this first one would be 2 minus 1. This one would be 2 times 4 minus 2 times 1. 2 squared is 4. And the last one, 4 thirds times 2 cubed minus 1 cubed. So that's 1 plus 6 plus 4 thirds. That's be 8 minus 1 is 7. So it's 7 plus 28 thirds. And again, leave it like that. You could also, 21 plus 28 over 3. 49 over 3. Okay, so that was the November 13th homework. Remember, you had the 2 forms of the fundamental theorem. This was to evaluate this definite integral, we used the first form we talked about, but there's that other one too, and there are problems on that in number 4. Okay, and then there was a November 20th homework. How am I doing here? Oh, fine. And this is when we got into exponentials and logs. And let's see. Well, let's do one of, I'm going to a couple of these. Number 2. How about this one? Log base 10 of 1.25 plus log base 10 of 80. And the instructions were to find the exact value. Well, actually, that is the exact value. Apparently meant it in a simpler form. Okay. All right. So that means we're going to use the properties of logarithms. So how would we do this? Log base 10 of 1.25 plus log base 10 of 80. That's log base 10. So I want to see about powers of 10. I can kind of get in here. Log base 10 of 1.25 is 125 over 100. Write it that way. And 80 is 8 times 10. So this would be log base 10 of 125 minus log base 10 of 100 plus log base 10 of 8 plus log base 10 of 10. Remember, all these logarithms have this property, this property, and this property. Okay. So I've used the first two. And let's see, what does that do for me? Well, that's all of this then is equal to, okay.
Professor Kennedy,
Yeah.
could you just use the log base 10 of x times y on the original formula and get the same answer?
Yes, you could. And I think that's a better strategy. Okay. Thank you. Okay. Yeah, no, I'm still going to wind up with this and this, which are not going to be nice. I think that's better, Mr. Yes. Okay. So let's change strategy here. I think that's a better idea. Okay. That's going to get rid of that 1.25. Yeah, it's going to turn it to 1.25 times. Whoops. 1.25 times 80. Right. All right. So log base 10 of 1.25 plus log base 10 of 80 is log base 10 of 1.25 times 80. Okay, so let's see what that is. 1.25, that's 5/4 times 80. And then 4 goes into 80 20 times. Oh, yeah, that's a lot easier. Okay. So this is log base 10 of 100, which is log base 10 of 10 squared, which is 2. Thank you for your help, Mr. Levy. Okay, let's see. Let's do another one of those. Oh, how about... Oh, another integral. You had, some little equations to solve, domain and range of domain of f and f inverse. Well, you would have found the domain and range of both of them if we did that. Let's see, you had some more graphing problems, and you had some more integrals. Oh, let's do one that requires a u substitution here. Let's see. How about that last one? So This is still the November 20th homework. And do this integral from 0 to 1 of x2 to the x squared. I'm having a hard time reading that. I think that's what it says. Okay. Well, we'll work it anyway. Okay. A U substitution's really good idea here. In fact, without that x sitting there, this would be a really hard problem. Okay. But you're going to let u equal to x squared. So du is 2x dx, and 1/2 du is x dx. And I've got x dx sitting in there for me. So this becomes now I did a u substitution, which means that my endpoints changed as well. Okay. And you can either go back in and change those, but I'm just going to write u of 0 and u of 1. Just to remind myself that 0 and 1, they're not the endpoints for the u interval. U at 0 and u at 1 is, well, actually they are in this case, because 0 squared is 0 and 1 squared is 1. But that's not always the case.
Excuse me, Ms. Kennedy, what did you write right there on that thing?
You mean the endpoints of the integral?
Yeah, you write ULSS and ULOS?
No, u of 0. Okay, u of 0 and u of 1.
Yeah, I couldn't tell what that was just by looking at it.
Yeah, it's a little bit awkward. Writing at the angle that I'm sitting in. So let's see. Let's finish this. Yeah, okay. There, that's more clear. Okay, so that becomes 1/2 du and 2 to the u. Okay, so the 1/2 can come out. And then I have to integrate 2 to the u. And 2 to the u, well, it's like e to the u. Any derivative, like, okay, there are air quotes around that. Any derivative of e to the u is e to the u. Any derivative of 2 to the u is 2 to the u divided by ln of 2. Okay, you get that extra constant in there because 2 to the, base 2 is not natural, okay? Base e is. Even though e is this weird irrational number. Okay, and okay, I still have my u endpoints. And yes, they are 0 and 1 here. But that's not generally the case. They're not generally the same. Okay, so if I go back to my x's, then the endpoints go back to being the original ones. So that's 1/2 ln of 2. 2 to the 1 is 2. 2 to the 0 is 1. So that's just 1/2 ln of 2. Okay, so that was a November 20th homework. And the other one is the one you just did. Oh, let's do the problem I screwed up. How about that? Yeah. This little short one on areas and volumes. I'm going to do 1C, but add x equal to 0, x equal to pi over 2 to that region. Because otherwise, the problem has no solution. You'd get a lot of bounded areas, all right, but they wouldn't. You get an infinite number of them, and you can't sum all of those things up. Yeah, you're talking about series next semester. Right now, it's something we don't even want to think about. Okay, so I'm going to add those two conditions, and you also have y equal to sine of x and y equal to e to the x. And you want to find the area of the region bounded by these curves. Okay, so let's draw a picture. Y equal to e to the x. Okay. It just actually goes up fast. Yeah. And y equal to the sine of x. Okay, sine of x, call that pi over 2. Oh, in fact, that's where I stopped. Okay, so x equal to pi over 2 is a vertical line, x equal to 0 is a vertical line. The region enclosed then is this one. And its area, okay, well, you want to go from top to bottom. So an approximating rectangle would look something like that. The rectangle would go from the sine x curve up to e to the x. So the area is going to be the integral from 0 to pi over 2 of e to the x minus the sine of x dx. And
The width would be delta x.
Pardon?
And the width would be delta x.
Yes. Yeah, so it'd be something like the height e to the x by minus sine of x by delta x, and you'd add up those. Yeah, that would be the Riemann sum approximating the area, so that translates to this integral right here. Okay, so this is e to the x minus plus cosine of x, right? And that goes from 0 to pi over 2. So that would be e to the pi over 2 plus the cosine of pi over 2, which is 0, minus e to the 0 plus cosine of 0. And that's e to the pi over 2 minus 1 plus 1. So e to the pi over 2 minus 2. And that is a positive number. Always like to check that. Integrals aren't always, definite integrals aren't always positive, but if a definite integral represents an area or a volume, it has to be positive. Okay. I don't know. That's everything, I guess. That's one problem off of each homework, and 2 off of the November 20th and November 13th, which have been since the last exam. And that pretty much uses up our time. Okay, so I'm going to end class. Next time to meet, Thursday. Can get your exam off Blackboard and start at 7:30. So I'll open up Zoom early too. All right. And get that thing taken so that you don't have to show up on campus and take it in person. I got to be able to see it on camera. Okay, I'm going to end class. If you want to hang around and ask a question, please feel free.
All right. Bye, Miss Kennedy.
Bye-bye.
Have a good day.
You too.